You're recording. Hello, I'm John Cusimano with AE Solutions. I'm joined by Tim Gale and Jacob Morella, and today we're going to be presenting applying PHA methodologies such as HAZOP and Bowtie to assessing industrial cybersecurity risk. Quick introductions about ourselves. As I said, I'm John Cusimano. I'm the Vice President of the AE Solutions Industrial Cybersecurity Division. My background is in process control and automation, functional safety, and industrial cybersecurity.
Hi folks, my name is Tim Gale and I'm a senior specialist in our industrial cybersecurity group. And similar to John's background, my background is in process control and process safety and industrial cybersecurity.
Hi, and I am Jacob Morella. So I'm actually a chemical engineer. I started out in plant operations before taking on a role in functional safety and process safety management. Worked there for a while and then moved into our industrial cybersecurity group to focus on developing processes for cybersecurity risk management and analyzing cybersecurity risk, in particular with focusing on applying some of the lessons learned from process safety to cybersecurity.
So today, our agenda, we're going to talk kind of through the process. We're going to start with really actually a connection between process safety and industrial cybersecurity, and then move into a methodology called Cyber PHA, which looks at the implications of cyber incidents using a PHA or HAZOP style approach. We'll take a little look at what are the results of a cyber PHA look like, then talk about Bowtie analysis, in particular, how could we use Bowtie analysis to help visualize cybersecurity risk assessment results, show you a couple examples, and summarize. Before we get into the details, being a process safety conference, I'm sure everybody is familiar with this diagram showing the basic layers of protection, both preventative and mitigative layers of protection and response layers. What we want to show here is how can the instrumented independent protection layers, how could they be impacted by a cyber incident, and how could that affect process safety? And the main way, of course, that is possible is that the basic process control, the alarm layers of protection, as well as the safety instrumented system layers of protection are controlled by digital control systems, either basic process control systems or safety instrument systems, or both. And modern BPCS and SIS systems are often networked, and those networks are often connected to the plant network. Those plant networks are often connected to the business network, and the business networks are connected to the internet. So modern control and safety systems, particularly where they might be integrated, can be subject to cyber compromise that could impact one or more independent layers of protection at the same time. So that concept, of course, of needing to protect define our layers of protection and implement those are covered under process safety and functional safety standards that I have up top. Quite independent from those, there are IT cybersecurity standards and OT cybersecurity standards that we have at the bottom. And those are all kind of wrapped with a layer called the NIST cybersecurity framework. So quite independently, IT and OT cybersecurity standards have been developed over the years. And at the same time, we have our functional safety and process safety standards and regulations. The connection between the two, process safety and cybersecurity, has not been lost on industry experts and standards bodies. And that's where we're starting to see things like the two clauses that were added to the IEC 61511 back in 2016, talking about the security of safety instrumented systems and the importance of conducting a cyber risk assessment. And then also we're seeing other standards, what we call bridging documents, standards that talk about both functional safety and industrial cybersecurity. And probably the most predominant one in that category would be the ISA Technical Report 84, coming from the ISA 84 committee, and talking about the process safety and the cybersecurity implications. So let's talk about the cyber PHA methodology and how this methodology helps bridge the gap between cyber security and process safety.
All right, so I'll go ahead and get started on what is a cyber PHA. One of the first things that I want to bring up is that it is not a replacement for a PHA, a process safety PHA. This is an additional separate study that you would conduct that focuses specifically on cybersecurity. It's consequence driven and aligned with ISA standards. Because it is consequence driven, that actually allows us to leverage some existing studies. So we can take PHAs, take some of the information from those and bring it into this, so we're not doing double work on that. There are multiple methodologies, just like there are for PHAs. The most common methodology we see for PHAs is HAZOP. So that's really what the cyber PHA is based on. And I'm sure everybody knows that's a very mature and well-developed methodology. At its core, this is really a team activity, just like your traditional process safety PHA. You really need input from multiple subject matter experts, people who know how the system operates, how the system's used, and what the business requirements of that system are. So this isn't a process that you can just go through and complete with one or two people. So the cyber PHA really takes the methodologies from process safety and extends and adapts it for cyber risks. So just like the PHA process, we're looking at causes of a deviation, whereas the PHA typically focuses on reliability and hardware failures or human error. A cyber PHA is focusing more on tampering or issues with the control system itself. The reason that's a little bit different is the traditional PHA covers your hardware failures, right? Or your instrumentation failures. What we're really looking for is some worst case consequences and causes that could be affected by cyber scenarios, and then building out the threat sources and threat scenarios that could lead to that. So it's very much focused on the potential causes of a cyber event and how you prevent each one of those potential causes. So here's the whole process. This is just a quick condensed overview. I want to give you an idea that this is not just a risk workshop. There's a lot that goes into this process, just like there's a lot that goes into a regular PHA behind the scenes. So we start out with documenting the system. So you'll see here we have an architectural diagram, inventory, data flows. You can think of that like information you would collect for a PHA, right? Similar to your P&IDs. You really have to have an as-built view of the system if you're going to effectively assess it. The second part there is a vulnerability assessment. So because there aren't well-documented and well-published likelihoods available for cybersecurity, because for a large part we're talking about intentional tampering, you need a way to help you determine what those likelihoods are, and vulnerabilities are a very important part of that. So it tells you how accessible the system is, how easy it is to compromise the system, and you'll use that information in the workshop to help you develop the likelihood. We also partition the system. So just like you would break a P&ID and a process down into nodes for a PHA, we break the network and the network connected systems down into zones and conduits that we can then look at and analyze in smaller, more manageable pieces, just like you would do in a PHA. The risk assessment workshop itself, I've already talked a little bit about. That's where we all get together and talk through potential causes, consequences, likelihoods, protection measures. You'll see just above that there's a cyber consequence assessment. Now that's where before the meeting we'll take all the available information, say for example from the PHAs, and kind of parse through that and look for scenarios of interest. It really gives you a good high-level look at the risk and what you can pull into the study itself. The final part there is mitigation planning. Mitigation planning really is just looking at the recommendations and finding what recommendations are not only the most useful, but also the most cost effective. So you can do effective prioritization based on risk and how effective those mitigations may be. So a lot of the outputs of this will be similar to your traditional PHA. We'll export the worksheets, export the recommendations. You can export countermeasure lists. So very similar to a PHA, but much more focused on cybersecurity.
Thanks, Jacob. So cyber PHA results. They're presented here in a tabular format, very similar to how a traditional PHA would present its results. And there's a large amount of valuable information that we contain in these tables, but the leadership has sometimes a difficult they have difficulty interpreting this and following the train of thought from consequence through to recommendation and how those tie together. And we're going to ask leadership to make some decisions on funding, and we're going to try and have them understand these scenarios. And so we would like for them to be able to have a methodology that's easier to understand than this tabular format. So we look to something called Bowtie. So just a quick refresher for those of you that may be familiar or just kind of learning about Bowtie. Simple process that graphically depicts pathways from cause to consequence, and we use them to help us illustrate high-risk events. It's intended to communicate ranges of causes and consequences of an event and controls, called barriers here, controls that are in place to reduce the risk. So we see on the left, we start with causes. We would find preventative barriers on the left side of this bow tie. Then we would arrive at a top event, things like loss of control or loss of view of the process. And then we would move to the right through mitigating barriers and finally arrive at consequences. So how does this help us visualize these results? This graphical view of a risk scenario that we've pulled from a PHA and converted to a bow tie depiction allows us to follow the sequence of events from cause to consequence much more linearly without a table full of codes and colors and various other pieces of information. So let's look at an example that we've pulled from a PHA, and we'll compare that to the bow tie depiction of the same scenario. So as I said earlier, the PHA results are shown in a table format. Oops. And this table format requires some knowledge of the PHA process to interpret. Whereas the bow tie on the right side of the screen shows us a much more visually intuitive view of the scenario and allows us to look at before and after snapshots it lets us look at the scenario unmitigated with no controls whatsoever. And then we can look at the scenario with existing and recommended controls.
Thank you, Tim. And just to kind of wrap things up here then, hopefully it was clear to you that the Bowtie can help provide an intuitive graphical representation of complex risk assessment tables. Much easier for particularly a layperson to look at a Bowtie and understand the relationship between cause and effect than they can by looking at tables. Minimal effort really to generate Bowties from existing PHA results, particularly when you focus on the high risk scenarios. The nice thing is you can also, as Tim had shown, we can have both the before and after view of scenarios. So what it is currently and what it could be if we add additional barriers. In fact, in some cases, less complex facilities, it is possible to just directly start with the Bowtie and not necessarily go through a full cyber PHA. But we have found, as Tim mentioned, it's generally much more efficient to work in the tabular format when developing the information through a cyber PHA, and then use the Bowtie for visualization. And the other benefit with Bowties is that we can, or someone can create Bowtie templates for common scenarios. So rather than reinvent the wheel every time, certain, for example, unit operations and the different threat scenarios that are commonly seen could be templatized, and that would make the work much quicker. So thank you everybody for joining this session. Again, myself, John, Tim, and Jacob are available for Q&A, both here on this forum, as well as through our email addresses, which are provided below.